Hello, we are here in the first passion workshop in Guimerà, and we have Professor Roger Guimerà with us. Professor, could you tell us a few words about your institution and work?
Yeah, I work at Universitat Rovira Virgili in Barcelona. This university is relatively young, but I have a joint appointment with the Catalan Research Institute, so it's a research position, and we do research mostly on complex systems and at the interface of statistical physics and many other fields, from biology to sociology, and also in the development of new tools to analyze data, and there we intersect with machine learning and statistical learning.
So it's a very broad interdisciplinary.
Yes, there is a core of methodological projects in which we work on inference on networks, on interpretable machine learning, and so on. But then we also work on the applications, and there we are completely promiscuous, and we work with all different fields, from biologists to sociologists.
Wonderful. What are your views on the impacts of machine learning on your field and maybe artificial intelligence on society in general?
Well, I think that in the field of complex systems, there is a two-way interaction, right? So I think some problems in complex systems benefit from machine learning techniques and tools. So to make predictions about complex social processes, for instance, right? But it's also true that complex systems contribute to machine learning, right? So I think it goes both ways. And the reason why it goes this way, which perhaps is more strange or less expected, is because statistical physicists develop tools to analyze systems statistically, right? Mm-hmm. And in many senses, that's very often what we do in machine learning, right? So it's really, there are often very precise analogies between people doing statistical learning and what we do in statistical physics. Then, for the other direction, we deal with complex biological systems, with complex social systems, and the predictions, for instance, that we can get from machine learning are sometimes very important, right? And the learning we get from those predictions, from the fact that we can predict the system, or we can predict the behavior of a system versus other systems in which perhaps we cannot predict the behavior, or learning about feature importances, these are all inputs that we can get from machine learning. For society, I think it's a bit complicated to say. Obviously, machine learning is having a huge impact, artificial intelligence is having a huge impact in society. I think we have to be careful that the impacts benefit the majority and not just a few.
I see. One last question. Is there anything you're particularly either excited or fearful about artificial intelligence in the next decade or next few decades?
Well, lots of things in both, but perhaps what excites me the most at this point is having machine learning help us to do science. I think that, as we've just seen with the two Nobel Prizes in physics and in chemistry, I think there is a very fruitful cross-fertilization between scientific disciplines, natural sciences, and machine learning. And I think that applying, in particular, machine learning or artificial intelligence to science to help us move faster in the discovery of how the world works, I think that's what excites me the most.
Thank you so much for your time.
Thank you for having me.
Your answers, and goodbye, and thank you for hosting us.
Thank you.